All right. So this is a video that I wanted to do. I was actually going over this, back over this myself, but I figured, hey, let me go over it with some of you guys. Maybe there's ones like myself that, you know about the PlayStation, you know about the Xbox, but do you really know like how the thing actually works? Do you really know exactly what you're developing for and on and how everything works? And this came about because next year, one of my goal is, well, it's not one of my goals, the goal is to deepen my learning with like everything that I use. So I've been using Unreal Engine and Blender and some other things, but it's like how do those programs actually work? Like the PlayStation 5, right? That's what we're finna watch now. It's like how does the thing work? Yeah, I know that it has a faster SSD and a power supply and all the rest of that, right? It's basically a computer. But how is it actually working? Do you really actually know how? And this kind of came about because I was watching. There's a 6 video documentary that Microsoft released. I heard it was on Netflix already, but it was released on YouTube yesterday, day before yesterday. And I'm watching the whole thing, and it's like the guys who came up with like the base code for the GPUs, pretty much are the reason why Xbox are here today. And it's like I want to know like that level, like developing graphics on a code based level, on a pixel based level. I'm only mentioning pixels because I went over what a SSD was earlier today. But it's just like I want to get deeper so that I understand. Like I use Unreal Engine, right? Which the cool thing is they released a Matrix little short demo last week. But you can go through the demo and you can pause it and turn the lights and turn the lights on and off and really see what is going on under the hood on a console. And it's just like, yo, I want to understand on that type of level. I want to know when my game crashes, what happened and where to go exactly go fix it in code, you know. So that's the goal for next year. And I figured, why not start with those who um, are the founders of this stuff? So one of the videos that I'm going to watch is Mark Cerny. And again, I've seen this last year when it first came out, and I was going to go over it again, but I figured, hey, let's go over it with you guys and maybe some, well, you should learn a lot if you're interested in it. Maybe learn something new, and I can share what I do know, and maybe we can all learn something new together. Shorten this up, get my shiny head out the way. My Steam over, I mean, I'm having trouble with my overlay, so I gotta do it manually. All right, here we go.
Hi. Unfortunately, we had to cancel the talk that we had planned for GDC. But we do have some super exciting news about PS5. And who better to bring that to you than the one and only Mark Cerny. Without further ado, over to you, Mark.
Thank you, Jim.
Thank you, Jim.
There will be lots of chances later on this year to look at the PlayStation 5 games. Today, I want to talk a bit about our goals for the PlayStation 5 hardware and how they influenced the development of the console. I think you all know I'm a big believer in console generations. Once every 5 or 6 or 7 years, a console arrives with substantially new capabilities. There's a lot of learning by the game developers, hopefully not too overwhelming, and soon there's games that could never have been created before. Now, it used to be that as a console designer.
Right quick, I'm gonna do 2 things right here and smalling this up a little bit. And I'm gonna be pausing it and talking about things a little bit. So the PlayStation 2 had the emotion engine, but I heard it was really hard to develop for. And I think the PlayStation 2, well, I think it was the greatest console at its time. The PlayStation 3 got messed over because of the pricing, and the Xbox 360 dominated at that point in time. But just for a little bit, though, because the Red Ring of Death killed it.
Or you'd somehow intuit what would be the best set of capabilities for the new console, and then build it in complete secrecy. For the PlayStation consoles, that period lasted through PlayStation 3, a powerful and groundbreaking console, but also one that caused quite a lot of heartache, as it was initially difficult to develop games for. So, starting with PlayStation 4, we've taken a different approach, roughly centered around 3 principles. The first of these is listening to the developers, which is to say that a lot of what we put into a console derives directly from the needs and aspirations of the game creators. We definitely do have some ideas of our own, but at the core of our philosophy for designing consoles is that game players are here for the fantastic games. Which is to say that game creators matter. Anything we can do to make life easier for the game creators or help them realize their dreams, we will do. So, about once every 2 years, I take a tour of the industry. I go to the various developers and publishers, sit down, and discuss how they're doing with the current consoles and what they'd like to see in future consoles.
Okay, that's very important for you as a developer to do, either solo or with the team, is to look around and see what other companies is doing. See what other companies is doing, see what they're developing, see what not the games, but the technologies. Okay. See what's going on so that you can see where you need to be headed, or what tools that you already have that you can advance. So that's an important thing to do as a developer. And it's important for this company to listen to developers, because they're going to be the ones making stuff for the game. I mean, for the console. If Nintendo would do this, they would have more third parties.
This requires weeks on the road, as reaching the bulk of the game creators involves talking to well over 100 people at something like 24 publishers and developers. And it is incredibly valuable. By the way, the feature most requested by the developers, that was an SSD, which we were very happy to put in the hardware, but a lot of problem solving was required. I'll be doing a deep dive on the SSD and surrounding systems later on in this talk.
Okay. SSDs make everything faster. They are faster than hard drives. You have a hard drive, and then you have an SSD. The SSD is made in such a way to where data is stored and distributed back and forth to through your console, through all your computer systems faster than a hard drive could, which is the reason why I believe Nintendo never wanted to go CD in the beginning. They went CD with their GameCube and the 2 Wii consoles, but after that they went back to cartridge. But they have been, I think, pro cartridge for a long time, and the simple reason why is because it takes longer to get data off of a CD. But at the time, CDs could store extra data that could speeding up the process, and they couldn't do full motion video. Full motion video is recorded video, full motion generated video to a CD. The cartridges could not do that. There was one game, to my knowledge, Pokemon Snap, that did it, and actually, as far as loading on a cartridge, Doom 64 loaded, but other than that, it was faster to go cartridge versus a CD. So thus you get the new age SSD, which is faster than a hard drive that has a CD in it.
It's also key to make a generational leap while keeping the console sufficiently familiar to game developers. I think about this in terms of balancing evolution and revolution. Now, with PlayStation 1, 2, and 3, the target was a revolution each time with a brand new feature set. That was great in many ways, but time for the developers to get up and running got longer with each console. In the past, I've called this time to triangle. Here's what I had for those 3 consoles. To be clear, I'm not talking about time to make a game. Developers will be ambitious, and it may take them 6 years or so to realize their vision. What I'm talking about is that dead time before graphics and other aspects of game development are up and running, and trying to minimize that. On the other hand, if we're trying to reduce that dead time to 0, that means the hardware architecture can't change at all. We're handcuffed. We need to judge, for each feature, what value it adds, and whether it's worth the increase in developer time needed to support it. So with PlayStation 4, we were able to strike a pretty good balance between performance and familiarity. We got required learning back to PlayStation 1 levels. With PS5, the GPU was definitely the area we felt the most tension between adding new features and keeping a familiar programming model. Ultimately, I think we've ended up with something under a month of getting up to speed. That feels like we're striking about the right balance. I'll go into a bit more detail later today about our philosophy with the GPU and the specific feature set that resulted from it. It's also very important for us, as the hardware team, to find new dreams, by which I mean something other than CPU performance, GPU performance, and the amount of RAM. The increase in graphics performance over the past 2 decades has been astonishing, but there are other areas in which we can innovate and provide significant value to the game creators, and through them, the players.
Okay, so he just mentioned 3 basic components that whenever you go to want more power or to get, like, you want a faster computer, right? Those are the 3 components you always go to. You always go to the GPU, the CPU, and he mentioned something else. GPU, CPU, and the memory. Like, those 3 things, like, you tackle first. But, in all honesty, a good coder, if he can go in and reprogram and really go into the GPU and the CPU and really figure out some things, there's a lot of untapped memory in every GPU that you get and every CPU that you get, even in onboard motherboard graphics. There's power that can be held within those consoles. If you go back, there's a talk, his name Andy, I think it's Andy Gavin, the co-founder of Naughty Dog. The way they got Crash Bandicoot to run on that console is because they actually went in and tweaked some base code, basically, on the PlayStation itself to get that game to do the things that it did at that point in time. Now, it looks like nothing today, but yet and still, I really think that tradition, especially with Naughty Dog and some of Sony's first-party developers, is handed down. Like, they know how to go in there and tap into the console themselves to retweak some things, to use some untapped power to get their games to run in the way they do. And don't quote me on this, but I will go to say, as far as what's the name of that game? I mean, Resident Evil on GameCube, I think it did that. For some reason, that game does not seem like it should have had a ran on the Nintendo GameCube. It just seemed like it was a lot at that point in time. And it came at the end of this, I think it came out about the end of the GameCube's life cycle too. So it's just things like that is kind of like, you know, that console, those graphics cards can actually do more than what the developers is able to do with them. The PlayStation Pro too, I think it can run Destiny at 60 FPS.
That's why the SSD was very much on our list of directions to explore, regardless of what came out of the conversations with game developers and publishers. The biggest feature in this category is the custom engine for audio. That's today's final topic. The push for vastly improved audio, and in particular 3D audio, isn't something that came out of the developer meetings. It's much more the case that we had a dream of what might be possible 5 years from now, and then worked out a number of steps we could take to set us on that path. So here again are the 3 principles, the first being enabling the desires of developers to drive the hardware design. To me, the SSD really is the key to the next generation. It's a game changer. And it was the #1 ask from developers for PlayStation 5. As in, we know it's probably impossible, but can you put an SSD in it? That was a discussion we were also having internally. It was clear that the presence of a hard drive in every PlayStation 4 was having a positive impact. A lot of things that would simply have been impossible at Blu-ray disc speeds were now possible. At the same time, though, in 2015 and 2016, when we were having these conversations, developers were already banging up against the limits of the hard drive, and a lot of developer time was being spent designing around slow load speeds. I want to focus in on just one number here, which is how long it takes to load a gigabyte of data from a hard drive. The difficulty being that hard drives are neither particularly fast nor flexible. If all your data is in one block, which is frankly not very likely, you can load 50 to 100 megabytes a second, depending on where the data is located on the hard drive. Let's assume it's on the outer edge, which means loading a gigabyte takes 10 seconds. If you compress your game packages, you can fit more data on the Blu-ray disc and also effectively boost your hard drive read speed by the compression ratio. We support zlib decompression on PlayStation 4 that gets you something like 50% more data on the disc and 50% higher effective read speed. Unfortunately, though, it's highly likely that your data is scattered around in various files on the hard drive, as well as sourced from multiple locations within those files. So lots of seeks are needed at 2 to 50-ish milliseconds each. My rule of thumb is that the hard drive is spending 2/3 of its time seeking, and only 1/3 of its time actually loading data. Putting all of that together, a gigabyte is very roughly 20 seconds to load from a hard drive. Now, a gigabyte is not much data. Games are using 5 or 6 gigabytes of RAM on PlayStation 4, so boot times and load times can get pretty grim. Or to put that differently, as a player, you wait for the game to boot, wait for the game to load, wait for the level to reload every time you die, and you wait for what is euphemistically called fast travel. And all of that leads to the dream. What if we could have not just an SSD, but a blindingly fast SSD? If we could load 5 gigabytes a second from it, what would change? Now, SSDs are completely different from hard drives. They don't have seeks as such. If you have a 5 gigabyte a second SSD, you can read data from 1,000 different locations in that second, pretty much at speed. As for time to load a gigabyte, this is next gen we're talking about, so memory is bigger. Instead, we should be asking how long to load 2 gigabytes. And the answer is about 1/4 of a second. I mean, that's amazing. We're talking 2 orders of magnitude, meaning very roughly 100 times faster. Which means at 5 gigabytes a second for the SSD, the potential is that the game boots in a second. There are no load screens. The game just fades down while loading a half dozen gigabytes and fades back up. Same for a reload. You're immediately back in the action after you die. And fast travel becomes so fast it's blink and you miss it. As game creators, we go from trying to distract the player from how long fast travel is taking, like those Spider-Man subway rides, to being so blindingly fast that we might even have to slow that transition down. Pretty cool, right? But for me, this is...
All right, I'm gonna cut the video here and talk about this right when I boot right back up.